И сейчас продолжим про AI, machine learning и test automation. Встречайте. Daniel Gold will tell us about how AI and machine learning is changing test automation. Please welcome.
Hi guys, how's everybody doing? This is like the worst possible time that one can give a speech. It's after lunchtime, everybody's sleepy. I'm half asleep myself. I see the back row over there kind of like snoozing on the chair. It's okay. Today we're going to talk about how AI is transforming test automation. Wow, this is kind of an ambitious statement, right? Well, let's see if I can back it up. So to those of you that didn't catch my speech yesterday, my name is Daniel Gold. I come from Israel. Back home, I work in a company called Testem.io, which is based in Israel. The R&D is in Israel, and we have a base in the United States. And you can visit our website. It's www.testem.io. And what we do is develop an AI and machine learning-based test automation framework. I'm the head of QA and automation at the company. I do some solution architecture. What that means is that I arrive at our customers' headquarters, and I kind of take a look at their product and their problems and their issues and their goals, and I try to help them to find the best way possible to implement test automation in their organization, which is kind of challenging because there's no one-size-fits-all approach, right? Every organization with their needs, their application, their technical challenges, their team with their skill set. So this is quite an interesting role. I love my job very much. I enjoy working in a startup. I love the technical challenges. I like the dynamic nature, if you will, of a role in the startup. I mean, in the startup, everybody does everything. I mean, except cleaning the bathroom. I mean, I do everything. Yeah, right. So I'm also a blogger. I have a pretty popular blog, I can flatter myself. It's called In God We Trust, The Rest We Test, in which I talk about test automation, I talk about software testing, methodologies. I kind of like spill my heart out. I talk about my work, about the frustrations at the occupation, some technical stuff. I did a review about Selenium 4 as it's about to be released. And I'm also a lecturer and speaker. I'm a freelance consultant and a lecturer in Israel. I have a company called Gold Training. And what I do, I provide advanced test automation and DevOps courses to individuals and companies. And I think that pretty much sums up me. By the way, this is the URL to my blog, danielgold.net. So if you want to, you can visit and kind of like kill me in the reviews. So enough about me, let's talk about you. I want you to please raise your hand if you are confused about the terminology of AI, machine learning, deep learning, if these things aren't definitely clear for you, please raise your hand. All right, I don't see a lot of hands up, so could please someone tell me what AI is, if you're all so confident about it? Excuse me? Okay, but what is it?
It's an intellectual agent that can perform some tests based on information that it can receive from its environment.
Okay, it's partially true. So here's the deal, guys. As time goes by, I hear more and more speakers going on stage and writing professional articles and addressing AI as being something, well, in a word, negative. Okay, it's kind of, they're describing it as something unpredictable that is difficult to contain or to control or to predict, none the least test, right? I mean, how can we test AI, right? Well, we can, but it's a whole other skill set, whole other technology, a new science field, right? Well, not really new, and not really that difficult. So the deal is that when asked to describe AI, many people fail to do so, but with that said, we hear so much famous speakers talking negatively about AI. I mean, I read some famous article back in a few weeks ago talking about autonomous vehicles, how it would be a disaster to send them out on the road, right? You probably heard that opinion, right? So I'm here to pronounce AI is already here. It's here, and it's embedded in our lives at this point or another. So if you ever interacted with Alexa or received a recommendation for the next Netflix movie to watch, chances are you are interacting with AI from this sort or another, but still AI or machine learning. Another good example is when you upload a photo to your social networks. We have automatic face recognitions, right, and age guessing. We have automatic tagging of people in photos. From the transportation field, I mean, we have autonomous vehicles, right, and auto parking. Tesla and Audi are doing a fantastic job. Well, nobody's perfect, but who's perfect, right? Google search, guys. We will receive different results for Java dependent on whether we are programmers or coffee makers, right? Because the machine learning algorithm will study who we are and what are we looking for most frequently and what are our interests or the data we input about ourselves. And it will provide an output based on what it knows about us. Now, if we kind of think about it, everything is data, right? Everything is data. Now, please raise your hand to those of you who think that AI is the source of all evil and is going to take over our jobs soon and something like that. Oh, only two? Yeah. Yeah. No. Okay, so I have good news and I have bad news. The good news are that Testem as a company, and me myself personally as a tester, I believe that no technology will replace the human mind, the human tester, his hands, his experience, his eyes, his error guessing. And this is my point of view. And the bad news are that I'm just a human and I'm frequently wrong, and soon I'll be replaced with AI, so we should ask it. So the agenda for today is, first of all, we're going to talk about AI. We're going to do like a breakdown of AI. We're going to try to demystify it, okay? We're going to take all of these big buzzwords we hear. We're going to try to understand them better. And then we're going to take this entire discussion a little bit closer to our home base, to test automation, and see how it can solve our challenges, okay? Our current challenges. And we're going to do like a glance in the future of AI in software testing and discuss how it might affect us in the future. So the basics of AI. Look, to make it very, very simple, AI stands for artificial intelligence. Someone here in the first row said it correctly. So AI, machine learning, deep learning, neural networks, it's all a subset of a data-related science field. So what this data-related technological science field addresses is the ability to give, to let computers learn without being explicitly programmed to. As I mentioned before, everything around us is data, and we can use this data and utilize this data to help us answer questions, to do tasks that by ourselves or manually or with less technological, more primitive ways would be very difficult to do, right? I mean, I just discussed some examples of when we see AI in our daily life and how much easier and more versatile it makes them, right? So I want us to get familiar with 5 key elements, 5 keywords that would guide us through this lecture and to just help us be on the same page and to talk on the same language, okay? So first of all, training data. As we said, everything around us is data. That is correct, but we need to find training data which is representational enough and clear and predictable enough for us to provide it to the algorithm to learn. That is what we call training data. The second word is collecting patterns and recognitions. Basically, what we need to do is to provide data for the algorithm and to tag it as a sortable data, and to provide it to the algorithms to learn and create patterns and modules within itself. Okay, it will pass some sort of neural network, which is basically like an entrance and exit points of input and output. Kind of like think of it as a decision table, but a lot more complex. And we have confidence level. What confidence level means is that how sure I am of my output. I mean, let's talk about an example. You know what? It's the next slide. So, a very primitive and basic example of how we can train AI is, let's take like 10 or 100 photos of a car, images of a car, okay? And we will tag them as vehicles, right? And we will provide them, feed them to our algorithm. This algorithm will collect this data and turn it into modules and patterns, okay? We can later on use these models and patterns to serve predictions. What this means is that if the 101 photo would be of a model of a car that the algorithm didn't see before, but it has four wheels, and it has a wheel, and it has 4 windows, right? And it's like the shape of a car. You know this joke about walks like a duck, sings like a duck. Oh, it must be a duck. So it must be a car. So this is one very primitive example of how training an AI would look like. To give input and to receive some sort of an output, right? Oh, that's a good boy. Looks like my neighbor's dog. Now, what we have just discussed, really in a nutshell, is called supervised learning, okay? Now, you know what, nowadays AI is the next big thing, right? Everybody talks about AI, everybody wants to do AI, but this is not a new thing. Quite surprisingly, it might be a big buzzword right now, but AI has been around for years, but just not so popular, right? So I see by your faces that you don't believe me. So I have prepared a video. So, just a second. So actually this video was published in 1992. Okay, as early as 1992, and according to what I know, this was shot at Stanford University back in 1989, as early as that. And this is one of the first experiments Stanford University did with autonomous vehicles. Let's watch it.
Artificial neural networks that learns to steer by watching a person drive. Alvin is designed to control the NavLab 2, a modified Army Humvee equipped with sensors, computers, and actuators for autonomous navigation experiments. The initial step in configuring Alvin is training a network to steer.
Okay, so now they're training it by observation.
While Alvin watches. Once every 2 seconds, Alvin digitizes a video image of the road ahead and records the person's steering direction.
They're kind of like feeding it images and letting it learn the human responses to the road.
This training image is reduced in resolution to 30 by 32 pixels and provided as input to Alvin's 3-layer network. Using the backpropagation learning algorithm, Alvin is trained to output the same steering direction as the human driver for that image. Initially, the network steering response is random. After about 2 minutes of training, the network learns to accurately imitate the steering reactions of the human driver.
So they kind of bombed it with images and let it observe, learn by observation. And as the algorithm got stronger and the patterns got stronger, it
This
went
same training
better and better
is
on
repeated
driving.
for other road types.
1992,
After the
guys.
networks have been trained, the operator pushes the run switch, and Alvin begins driving.
Okay, so look, no hands.
12 times per second, Alvin digitizes an image and feeds it to its neural networks. Each network, running in parallel, produces a steering direction and a measure of its confidence in its response.
So they're talking about the level of confidence on how it reacts to the road ahead. I think that's enough. You're tired enough after lunch. I don't want you to go get a sleep.
In this
Okay, so just a second, please. My internet connection here. Okay. So I wanted to show you one more example of how training in AI would look like. And there's kind of this website, demo website called QuickDraw by Google. So what they did, they were feeding it images of different shapes and forms. And later on, we can draw something and let it guess what we're drawing. So let's just try to do it for a second. So it's Quick Draw by Google. Okay, let's draw. Draw a bucket. Oh, let's try.
I see knee or nose or stairs. I
No,
see ear or
it's not a
stethoscope
nose, I
or
swear.
chandelier or wine bottle. I see octagon or computer mouse
Octagon.
or the Great Wall of China. I see river or bicep or necklace or avocado. Sorry, I couldn't guess it.
Ah,
Or blackberry.
I suck at this, I'm sorry. Let's try one more. Headphones, oh, I'm good at that. Let's see. Shit.
I see matches or line or magic wand or lollipop. I see knee or volcano or umbrella.
Where did
or
you see
rainbow.
like a volcano?
Oh, I know. It's headphones.
An axe, okay. Oh, it's a Mac, I'm not used to it. I'm sorry, I don't draw very well.
I see marker, or diamond, or baseball bat, or feather. I see potato, or circle, or leaf, or peanut, or comet. I see garden hose, or hurricane, or bow tie. I see gear, or seahorse, or brain. Sorry, I couldn't guess it.
Yeah, and I suck at this. You know what, just one more. It's addictive, I know. Diamond, all right.
I see garden hose, or gear, or dragon.
I didn't draw anything.
I see line, or seesaw, or stairs, or diving board, or the Great Wall of China. I see bench.
No, it's a diamond, I swear.
I see rainbow. Oh,
No.
I know, it's diamond.
Oh. I think this is the highest point in my career. I can just retire right now. In my defense, two things you can learn from this. The first one is how training an AI via feeding it images and then collecting a pattern would look like, right? And the second one is I suck at drawing. Okay, back to work. Okay, something I'm good at is test automation. So let's discuss how all of this is related to closer to us, to test automation. So if I take you back in the timeline, back to the more static eras of software development, right, with waterfall. I mean, there's still companies working like that, but once upon a time, okay, we had more time to do stuff, right? like software planning and design reviews, and until something was developed before it would be planned, like ages, right? And then the big bad agile wolf came, right? And everything has to be ASAP. Yesterday I need it. And the coverage gap has went bigger and bigger and bigger. We had bulky test automation tools. At the beginning, the test automation tools, it's kind of like 2 days to install, a month to learn, and once you install it, your computer would jam up for like a week. Followed by the open source revolution, right? With Selenium receiving something I couldn't fairly describe as global domination, Selenium and Appium. I saw a Dan's talk yesterday. So tools have been more adapted to the way we develop things, right? More agile, faster, more robust. And today we are in the era of continuous delivery, right, and continuous integration. Everything has to be frequent, very frequently releases, very fast approach, and everything has to be tested because we break things on a daily basis, right? So this whole thing lets us to believe that we need test automation. We cannot escape that, but there are main challenges in implementing test automation. Well, first of all, there's skill set, right? I mean, test automation requires skill set. There are code-based frameworks when you get nothing except API libraries, right? Bindings. There are tools that need some learning curve. The skill set varies according to the tool. And we have authoring time, because authoring, how can we describe authoring? We need to write an infrastructure, and before we get to an ROI, or return of an investment, you know, correct planning. I mean, something I always tell every company I go to is, before we write a single line of code, get a piece of paper, get a pen, show me what your system is made of, what your architecture, what are your goals, what do you want to automate, how would your structure and architecture look like, right? And if we talk about maintenance, then after we have test automation, a huge percentage of time would be invested in maintaining it, because we do so much change requests, we do so much changes in our super fast pace in our applications, that we have to maintain it all the time because tests break, okay? And there are flaky tests, all of that issues. And of course, scale is something that every organization strives to. Now, due to barriers of time, I'm going to talk about maintenance and maintenance only. So what I mean by maintenance? Well, first of all, let's understand how test automation tools locate elements in our DOM. Okay, anybody wants to answer that? How do we locate elements? Locators, selectors, right. So basically what is going on is that we have different ways to locate elements, okay? And excluding CSS selectors and XPath, which gives us a more flexible and better approach to identify elements, we're still going by a single property, a single element, a single unique identifier, right? Now, I want you guys to think about something. What is a DOM, actually? Okay, it's HTML tags, right? CSS, JavaScript, XMLs, right? All of that cool stuff kind of like mashed together into something called document object model. And now, if you come to think about it, this is all data. This is data we can use. So what Teston did, using AI and machine learning, is harness the power that AI and machine learning gives us to use dynamic location strategy. What that means is that I can take an element that I want to perform an action on, and I can study it, okay, I can capture it, okay, I can tag it, I can process it, via every property that I can collect upon it, okay? If I capture a DOM and I need a specific element, I have everything leading to that element, right? I have every property this element has. I have his parents, his grandparents, and this entire dynasty in my hands, right? So I know this does not mean a lot before you see it, and I just cross my hands right now that the internet connection is sufficient. And I'll show you. So this is the product, and this is not a demo. I just want to show you what I mean. So I'm starting to record a test. You know what? This is not good for us. This is not good for us because the screen capturing will not work. Okay, so what's going on right now is I'm doing kind of like a flow, right? And Testim records everything I do. I click on select destination, and I see I've arrived at this web page. Now, going back, I see that it captured my select destination button, right? And I can see it captured whole different elements and attributes and everything it could collect on it, right? Going back to his parents, his grandparents, everything I can collect with all of its properties and attributes, right? Now, I want to do something crazy right now. I want to get a breakpoint just before I click the select destination button, and I want to play this test case. God bless the Wi-Fi. So it's playing, as you see. Okay. Okay, and we have reached a breakpoint, right? Right, we have reached a breakpoint, okay? And now what I'm going to do is I want to break this element, right? So I'll click on Inspect Element. And I see this element in my console, and I see an ID, right? So I'm going to break this ID. I don't like it. And I see a text, so I don't like this text. Select destination is boring. Okay. Testing stage 2019 rocks. Cool. Okay. You know what? I don't like the entire location of this element. I'm going to take this entire element, okay, I'm going to click on cut, and I'm going to paste it like 2 divs above. Paste element. All right. So can anybody tell me what would happen to this test case if it was written by Selenium location? It boom, right? All hell breaks loose. So I actually broke everything I could find on it. I broke his ID, his text, his XPath, his everything. Okay? And now what I'm going to do is I'm going to play the scenario ahead. Okay? So I click play. Okay? You see it? It clicked on it. Okay? So the question is why, and I'll tell you why. So what we see right here is that it didn't find the text, right? We see that it's grayed out over here. And we see that it didn't find its index because we killed it, right? And we see that it didn't find everything he wants, and it didn't find it where it expects. But with a high level of confidence, with 83%, it was sure that this is my element because several attributes he found that were there before, he recognized and found them. Because the algorithm just worked, okay? So this is what we're talking about, dynamic location strategy, and this is what we're talking about when AI can assist us. I think that AI is an amazing tool when given to a tester. In the tester's hands, it can be an amazing tool. I think that testers can do wonders with it once you think about it. Just a second. Once you think about it, about the coverage gap and the all of the things we have discussed, that tests are breaking, we have flaky tests, and all of these frequent changes that cause our tests to fail, all of that things are just dropping off our agenda, and we can focus on writing test automation and executing test coverage without constantly worrying about maintaining our tests and kind of like, you know, I mean, I believe there are several test automation engineers in the audience. You know what hell it is to maintain test automation. Okay, and another thing that we learned is that if we can serve predictions, and if we can learn by observation, then we can take real-life data and real-life flows that a manual tester can do, and we can aggregate these actions and flows and turn them into real-life product user scenarios, which means that in the near future, we see how AI can assist us testers in producing test automation and producing regression flows based on what it learns by observing you, okay? So, look, two things I want to tell you that I hope that you would leave on today. The first thing is that I think Dan said it yesterday in his lecture, that the world was designed by people no smarter than you. I think it's Steve Jobs' quote. And don't just blindly believe everything you read in an article just because someone is a famous lecturer, or, you know, we're all individuals, we're all testers. Everybody, every one of us has its own opinion, and you're testers, we're all testers. Learn, investigate, get to the bottom of things, question everything you hear. And the second thing I wanted to say is that you have been an amazing audience. I talked to Victor yesterday, actually, and I told him how alive and different this audience is from what I'm used to in other conferences and back home. You're very active. I've seen you in other lectures, and I truly see people that have come here to learn and to observe. And I hope that, at least in a small portion, my lecture has given you a slight advantage and kind of like a look and feel of what AI is and what we can do to use it. I hope I didn't bore you too much. I want to thank you from the bottom of my heart for listening, for giving me the time of day to talk. Thank you, Testing Stage, for having me. You've been amazing. Thank you very much.
Questions?
First of all, thank you for your speech. I really enjoyed it.
Thank you.
And I have two questions.
Sure.
First, it's about this dynamic location. So does AI receive some kind of, like, is it also possible to use this as supervised learning? So for example, it failed to, like, it thinks that this locator is, this element is what you mean to do, but it's not. So can I provide like a negative feedback on this?
I'll answer it like this. When we wrote this algorithm, a part of this, training a neural network and designing it is also tagging data, okay? So we can tag data by sorts and correct and incorrect inputs to the point where our algorithm is stable and reliable enough to provide you the output that you would expect. Furthermore, we can, within the tool, we provide you the flexibility of unchecking some locators that you know by definition in your application that there are problems, that they are too dynamic, or there are all sorts of angular magic that the classes change every 2 seconds or something. I don't know. But we provide you with that flexibility. And the third part of the answer is that Right, I changed its index and I've demolished its properties, but there are other properties, there are tons of properties you can find about an element. It's like doing a research about you. I will find so much things besides your name that I can learn about you, that I can tell someone else without saying your explicit name, but they will know I'm talking about you. And that's what gives the algorithms the strength to be reliable. What is the second question?
Yeah, so, and the second question is about, can we receive false positives in some ways? I mean, generally, false positives are like taken as much more problem than false negatives.
Okay, I agree.
Yeah,
So
I remember about confidence level, but
yeah,
besides
I
of
know
that-
what you're asking. I understand the question. So the deal is like this. Nobody can say that their code, okay, is perfect. It just does not exist. And if it would to exist, we would be out of jobs, and we don't want that. But what I can say is that our number of false positives and false negative is reduced to a minimum. And why is that? Because in this flow I've shown you, this business flow, all I want to do is to click on an element, okay? I don't want to know if something changed, because all I want to do is to click it. A validation would have failed, but a click, I only want to click it. I will just, you know what, I'll switch it around a little bit. If I were to perform a validation on this element instead of a click, would I want the validation to find the element? Right? So this is what an algorithm is good for. You will find it, but the validation would fail because the text is different, right? And the color, I can change the color, it's different. Or the placement, the visual validation, like we have visual validation, you can, it will fail as well. So this is the answer.
Okay, got it. Thank you.
Thank you. Thank you very much. Anybody else?
Hi, thank you very much for your lecture. I have one question. When I was listening to your lecture, I started to think that you just show the flow, the basic flow, like you're logging into a web application. And do you have in your plans to make some, for instance, additional testing? So you're, I know that your algorithm knows that there is an input and you enter some value in that, and you can already predict some tests, so like putting some incorrect values and expecting some errors on the page. So it's like it's automatic testing. You just give it a flow, and it will run several tests to verify that there is error handling. You can put some incorrect values, or maybe some
data-driven. You're talking about data-driven.
Yeah, maybe.
Yeah.
Not only data-driven, but maybe some other also different scenarios even.
Yes, sure. We provide you with the flexibility to run the same test 20 or 30 or 100 times with different values and expect a different output. We provide you with that flexibility. This specific talk is not about the tool. I wanted to show you the algorithm and how AI can be used in that. But just in one sentence, because it's not related to sales, we have a free version that you can go to testem.io and download and work with it. And it's a framework with all the meaning of it. I mean, we have multiple functionalities out of the box. Looping, data-driven integrations, visual validation, negative validation, positive validation, whatever you want, the tool contains. And if it doesn't contain, I'll develop it for you. So this is the answer.
Okay, thank you.
Thank you.
Anybody else?
Have several technical questions about your product, basically.
Okay.
We are just, so let's start with, what language do you use to teach your models?
Language?
R, Python, to write
Okay, so here's the deal. We support JavaScript and Node.js, so you can you can work on the web application. So JavaScript doesn't need compiling, so you can just run your code inside the browser. And Node.js gives you the flexibility to use packages and to do whatever you want because it's Node, right? It's totally unrestricted. So this is the two options you have about coding. Basically, the motto is we work hard so you won't have to. So we try to reduce coding to a minimum, but when you do need flexibility, then you can do it via this code.
Okay. What tools do you use to evaluate the results?
To what?
To evaluate the results, to predict. So currently you send your test data to some server because it was referring to some internet connection.
Okay.
It was evaluated and replied to you that in case, not in case, but prediction is 83% that this is your element.
Mm-hmm.
So that means that somewhere there is a model which was trained by some test data. It's another question, how much data did you use to train this model? And which tool do you use to predict? Which is it Microsoft ML Server, for example?
No, this algorithm was written by us. It has been developed. Testing is around for like 5 years. So it took us a lot before that to try, and we were probably. No, I'm confident of that answer. We were probably the first to provide this kind of algorithm. So it's our algorithm. It pings our services. We also have an on-premise solution if you're concerned about some kind of data security or everything. We can put this algorithm on your server. So, but it's our solution. We don't use external tools. We do allow you to use external tools with integrations. So you can use, if you have been to Lior Katz's yesterday, presentation talked about code automation and visual validation, so we allow perfect integration with Apply tools or another test management tools, whatever you like.
So it sounds like it's secret, which tools and which...
It's our algorithm, sure. It's closed, it's a black box.
Okay, and the last one, which is, if you can share this information, so you use the model, it's somewhere, which size of this model? So
What do you mean by size?
Each model has a size. So when you feed data to train the model, store it, and it has some...
Actually, if you think about it, I mean, right, there is an algorithm to identify elements in the DOM, but each DOM is different, and each element is led by different hierarchy, right? So it kind of like captures the data it needs in runtime, and then it evaluates it every time it runs. So if something fails, it will fail it on the spot. This is the answer.
But it evaluates it against some model.
It evaluates against what it captures. For instance, I can visually show you, like in this point, select destination. If I open it side by side, I can see that it has been select destination, and at this point, it didn't recognize this button, right? It would be pinging to some place, but it didn't find it. So this is the answer I can provide.
Okay, maybe
Okay.
we didn't. Yeah, okay, maybe you didn't understand. I was.
If you have any concrete questions about the product, I will be more than happy to. After the lecture, I'm here.
Okay,
I won't run away elsewhere.
Hi, thanks for the presentation. Really great speech and product.
Thank you.
Is
my
it
pleasure.
working with Appium? Is it working only with web-based?
So we support mobile web. We support mobile in closed beta right now. We support all types of web applications. Our main target is functional end-to-end UI testing. Thank you.
Hi, thanks.
Hi.
It's very amazing too.
Thank you.
Did you had maybe cases when you have several iframes on the same page with very similar elements? For example?
Yes, we do. It's been a nightmare. I've actually been a part of the algorithm part that was developed. I actually joined the company when we were like 7 people. So I'm familiar with that part of the algorithm pretty well. So yes, we do multiple iframes, iframe inside iframe, layers of Z indexes, and all of that types of data is supported. We also have a unique way to present that it has passed through an iframe or several iframes, so you can know about it in our locators. You can see it. So the answer is yes.
Great.
Thank you.
Amazing, Sam.
Thank you.
Hi, thanks for the presentation.
Thank you.
I have a question about objects. I mean, can we save separate elements or scenarios as separate object, like a page object pattern?
Yes. Okay, so at times you would like to perform a set of actions on a testing area, let's call it like that, which will be recurrent. So we support something that is called context testing. So you can provide a context, and you can use that context in multiple pages and multiple tests you will have. Also, in addition to that, we allow you to utilize this concept of context. For instance, you have an entire list of checkboxes you want to, select all. So instead of select all, you can go and click each select box by providing a context. So once the algorithm sees that, okay, it's a line, it has all the markings of a line, okay, I think this is all the same li tags. Okay, so I'm gonna go through all of them and identify them. This is kind of a very strong algorithm. It's a unique functionality, but yes, we support it. We support our version of page objects, and yeah. Thank you.
Okay, guys, so have a good applause for Dan Gold, Daniel. Yeah.
Thank you.
So you can catch him afterwards.